Welcome. Today we're going to be talking about zero-order integrated rate laws. So for a reaction of chemical A becoming products, we can relate the rate in two different ways. We can talk about the rate as the change in the concentration of A with respect to time, so a negative delta A with respect to time, and we can also talk about rate in terms of the rate law, which is going to be a rate constant times the concentration of A raised to the zero power, since this is a zero order reaction. And just like we did with first order reactions, which you should have already watched, if we take these two expressions, so minus the change in concentration of A with respect to time, and set them equal to one another, and then do some cool calculus, we can come up with a relationship that shows how the concentration of A will change over time for a zero order reaction. And that relationship in my favorite form is that the concentration of A at time t is going to be equal to minus kT plus the initial concentration of chemical A. And this is going to be our core zero order reaction. If we take a look at this and think of it in a linear fashion, the concentration of A at times t, that's going to be our y. We're going to have mx being minus k, that's our slope, times the time, which is going to be what's on the x-axis. And then a naught is going to be our y-intercept, so the b term in a y equals mx plus b equation. And what this means is that if I go to graph the concentration of chemical A with respect to time, I'm going to find that I have a straight line, and the slope of that straight line is going to be minus k. This is incredibly useful. So now we have a way first to show that something is zero order, is the graph of the change in concentration with respect to time a straight line, and we can find the rate constant for that process just by looking at the negative slope. And remember that this is a the zero order reaction, and so the units on that slope are going to be moles per liter per second. So that's going to be our unit for slope. So let's do something with this. Here's a problem where I have chemical R turning into chemical Z, and you've been given data about the time and how the concentration of R has changed over that time. So the first question asks, is this reaction zero order or first order? To determine that, we're going to graph it. And so for a zero order reaction, I should be able to graph the change in concentration with respect to time. And if that's a straight line, it's zero order. If it's first order, if you recall, the graph that is linear is the natural log of the concentration of R with respect to time. When I take this and I actually do this graphing, I find that as the concentration changes over time, that looks pretty linear. But if I take the natural log, it's not so linear. So I have evidence in the fact that the concentration of R with respect to time, that's the linear reaction. That means that this is going to be a zero order reaction because this graph gives me a straight line. So first part of the question answered. The second question says, write the explicit rate law. So if you recall, your rate law, your general rate law, is rate equals K to whatever chemical it is raised to an exponent. Because we know that this is a zero order reaction, I know that I can find my value of K as finding the slope and taking the negative value of that from the linear graph. And so for this particular process, the slope was found to be a negative, so I'm dropping the negative sign because it's the opposite of that, 3.50 times 10 to the negative third. Be sure you write the units on your reaction rate constant, and then multiplied by the concentration of R, and I'm going to indicate that it's zero order because this is a zero order reaction and I know that it's zero order. So my explicit rate law is going to indicate both the order of the reaction here, and it's going to give a value for that rate constant. And that's what makes it the explicit rate law. The last part of this question says, how long will it take for the concentration to decrease to 0.50 molar? this is where you're going to use your integrated rate equation. For a zero-order reaction, the integrated rate law has the form: the concentration at time t is equal to minus kT plus the concentration at time 0. And so to answer this question, we need to use the information in this problem and plug our numbers in. So the concentration at time t, what I'm trying to find out about, is 0.050 molar. I know that my rate constant was 0.350 times 10 to the negative third. And I know that I'm trying to solve for time, and I know that the initial concentration was 1.55 molar. So at this time, all we need to do is solve the equation for T. And so there you see that we can use these graphical and mathematical relationships to both determine the order of a reaction and demonstrate whether it's zero order or first order, to write an explicit rate law, and also to calculate the concentration as time changes, or find the time it takes for the concentration to change.